Hi everyone, good morning. Welcome back to Pine Hollow Auto Diagnostics. We're taking a road trip today. We're heading west about 4 hours into Ohio for an urgent diagnostic call. Crazy story on this one. My friend Kip from ProMasters Only sent me a request for a ProMaster van that he says is possessed. Now, Kip exclusively works on these ProMaster vans, so he has a whole warehouse full of known good parts. So the story with this van is two Russian guys, expediter delivery guys, who don't know any English, so that's pretty interesting. They have this van that has a long history. I actually talked to the owners of the van, you know, the two Russian guys, and they told me, I mean, like you wouldn't believe, they've been having issues with this ProMaster. I don't know if it's on the original engine or not, but it's been having drivability problems for a while, and just recently it got so bad that it's only running on 3 cylinders. Apparently it's only running on the rear bank. So when this happened, they were about 50 miles from Kip's shop, so they limped it there, and Kip spent about 3 days swapping parts. I mean, he tried everything to get these cylinders to fire. You name it, coils, plugs, injectors. I mean, let's read what Kip wrote here in the request. Two Russian guys who are expediters live in this box truck. They're in serious trouble. Working in their van for 3 days solid. I'm at the limits of my abilities. They're willing to pay you to come here. Possibly can limp toward you. Van will run on flat ground, but hills are an issue. I give you massive amounts of detail. Short version is only running on the rear 3 cylinders. Front 3 refuse to fire, with codes being this insufficient ionization codes for the front 3 coils. It runs and drives on 3 is a miracle. I have piles of known working parts. Part swap testing includes engine wiring harness, computer coils, all 6 injectors with fuel rail, map, crank sensor, cam sensor. Air filters on coils, cams on bank 2 physically verified, compression tested, voltage good, all other data good, bank 2 cat stays cold to the touch, inductive coil test reveals bank 2 coils are firing. Coil duty cycle data tells me the computer is detecting the funky coils, not firing the injectors. Those 3 cylinders aren't hydrolocked or otherwise drenched. Plugs have fuel smell but aren't soaked or wet. My shop, which is fine, these guys need to get back on the road. You have food and a way to make tea. Well, that's key. If you're Russian, if you don't have tea, you're in trouble. So we'll get there soon. About another hour left. I'm looking forward to this one. Oh, I see some ProMaster vans. This must be the right spot. So, this is the beast behind me. And apparently what it does, it actually starts up smoothly and then cuts out the front bank of cylinders. So I didn't get that information. I thought it was just 3 dead cylinders, but considering that fact, we know that for a few seconds it runs nice, so we're not suspecting, you know, fuel delivery issues, but it is setting, just like the customer said, these secondary circuit insufficient ionization codes only on the front bank. How weird is that? Let's start it up, see what it does. Runs perfect. I mean, great. And then okay, cooling fans kicked on. Got a red light there. Okay, it's reluctant to rev. Got a blinking check engine light. Feels like a single cylinder misfire right now. Or it could be all 3 because it runs very evenly. Yeah, it's definitely not happy. So what's my game plan? Get the scope out and compare the good bank to the bad bank. Just on the ignition coil, see what the firing lines look like. The PCM is controlling everything. So let's do that. Okay, ignition coils. Here's the powertrain control module. They're all in connector C2, so they're powered by fuse 22, 20 amp, and then controlled individually by the engine computer. Now, where are these pins? So there's the connector, and I've labeled pins 1, 25, 49, 73, 74, and 75. So basically this bottom row and then these two are controlling all of the coils. 1, 2, 3, 4, 5, and 6. Doing a visual inspection on this connector, it actually looks pretty bad. The pins look wet, green, crusty. There's moisture in the connector because the cowls on these things, especially after a windshield replacement, apparently drip down and wreak havoc on the electronics. So connector C1 actually looks decent. I don't see any green crusties in C1, but there's water on top of this engine computer. There's water inside of the connector, and you can see the pins are actually getting kind of green and crusty. Isn't that crazy? So what we can do is, before cleaning anything, let's put a scope on there and see what the computer is fussing about. I want to compare, for example, cylinder 1 versus cylinder 2. We'll just put the channel 1 and 2 on these control wires, see what the spark line looks like, what the control looks like, and then on fuse 22 I want to put an amp clamp to see how much current these coils are drawing. Why is it fussing only about 2, 4, and 6? Because 2 and 4 are on this bottom row, 6 is right here. They're all green and crusty, but why just the front bank? So it's just lightly snowing outside, and this water is getting ridiculous. You'll see it just like squirts right there, and look, the PCM's getting nice shower right now, and then this is dripping right here, filling the plastic intake manifold up. So this cowl repair is not working at the moment. See, it's dripping right off of the wiper motor, and then coming off the reservoir. And once that little puddle fills up, let's wait for the shower. Here it comes. Oh, it's holding on there. Ready? Boop! Amazing. Alright, so we got the 3 channels set up. The blue and the red are ignition coils 1 and 2. I'll just put them on top of each other. And then channel 3 is the amp clamp on fuse 22, which feeds the ignition coils. Now, I don't know if the current's going this way or that way, but let's just fire it up and see if we see any signals. Okay, that's good enough. Flip my amp clamp around. Let's try that again. Did it instantly cut out? Yep, that's all we need. Alright, so we got some beautiful data, and you can see right here, it just shuts off the even coils. Isn't that crazy? It does not like something about the even coils. Now, let's look at the coil current ramps. As you can see, this one goes up to 1 amp. That's cylinder 2. And cylinder 1 goes up to that's 1 amp. That's about 0.7 amps. And indeed, bank 2 has the higher currents, and you can see a longer dwell time. Why does it have a longer dwell time? That's pretty crazy, isn't it? Bank 2 has a longer dwell time. Not just cylinder 2, but 4 and 6 as well. Now here they're pretty even. Let's see, let's zoom in right when it starts. See the current difference right there? The dwell time is getting longer and longer. Here it's getting bad. Here they're almost equal. Okay, so you see the burn line on cylinder 1. I mean, it's maxing out at 50 volts, obviously. The the initial spike, but there is some difference. Those are about the same. Let's look at here. It looks like there's more turbulence in number 2. Okay. And then it just shuts them off. Why is that happening? A little longer dwell time, then shut off. So we know the connector is green and crusty, so I'm going to do my best to clean that out, blow that out, take a close look at the pins, maybe some of the pins are bridging, and repeat the experiment after cleaning the connector the best we can. Yeah, we've got some major green crusties in this connector, especially bridging all of the coil control pins. I don't know if you guys can see that, right in that corner. Not surprising whatsoever. So maybe that's a strategy. If it feels one bad one on whatever bank, it just disables that bank. Who knows? But you can see that 1 and 2 are okay, but 3, 4, 5, and 6 are messed up. And we could probe one of the really green ones just for kicks. Then we're going to have to clean this connector out. That's pretty insane. Alright, let's repeat the experiment. I just moved channel 2 to cylinder number 4, which was more in the green crusty zone. Again, fire it up. It's happy. And then it does there. Okay, let's look at the data. So connector C1 looks beautiful. Connector C2 looks ugly. We're going to blow it out. Deox it. So we have to prevent the pins from bridging, then it should be okay. Okay, so we have some deox it, and I'm going to town on the computer connector with a little pipe cleaner, so we'll get all the green crusties out. Hopefully. Like a heat gun? No, we don't want to melt anything here, Kip. This is the man here.
I think it's my hero. He is my savior.
Well, we'll see here, Kip. Just give me a few minutes. Hopefully this thing will run on all cylinders very soon. Okay, we're looking much better here. Deox and a brush goes a long way. Then we'll take care of the actual harness connector. Maybe pop off that brown. Well, it looks ugly in this connector. The green crusties are wreaking havoc. All those pins are bridged, especially the lower ones for the coil controls. So we're going to blow that out, deox it, brush. Hopefully it will come back to life. Alright, looking a little better after a deox it and compressed air cleaning. I really hope the pins aren't bridging further inside the connector. I want to pull the pins. Let's reassemble it, plug it into the engine computer, and see if this thing will fire up. Alright, PCM's back in. I got a rag over the master cylinder so the water doesn't go directly on it. Scope is set back up. Let's get it rolling. All codes are cleared. Let's see what happens. Let's look at our data. Well, problem is, are we fixed or are we not fixed? Nope, it's still disabled. Coils. Let me hook up my ground. We still have a blinky check engine light. I guess it wasn't going to be this easy. Yep, 2, 4, and 6, insufficient ionization. Is it possible that the PCM could have been damaged due to this water intrusion? Perhaps. But hey, we don't have our transmission temperature light anymore. That must have been the other green crusties that we cleaned off. Alright, so exactly the same. It runs for literally 2 seconds and then sets codes for the 3 coils, 2, 4, and 6. Do we see any difference in, after the cleaning, any of the current ramps? Not really. So this is cylinder 4 right now. There's definitely combustion occurring when you rev it up. We can put I don't know when it disables the fuel injectors. Is that combustion occurring inside or outside the cylinder? See, the blue has more turbulence. The red is very smooth. Is that on all of them? Something there. Or did the PCM get damaged from the water? Start up. Revs fine, and then right there, boom. Same exact codes. Nothing changed. I want to see if, the fact that it revs up real nice right when you first start and then the engine computer cuts out the ignition coils tells me we have everything. We have spark, we have fuel, but still, the water in the PCM connector, that water could have followed the pins right into the PCM. Now this PCM is brand new. They only have like 300 miles on it. But, and they said like it didn't rain when this problem started. This problem was there with the old engine computer. Got a replacement engine computer installed. It's not programmed, but if it runs for 2 seconds, we should be able to see and compare what these ignition coils do and the injectors. So, let's see. Key on. Invalid skim key. Okay, yep. See if it'll fire up. Yeah, that's probably not going to be very helpful. Not very helpful. It's probably not long enough to set codes. Can we program? Can we program keys here? I didn't bring my key programming tool. Dang it. Alright, so one of the last experiments I want to do is check how watertight these pins are in the plastic connector. So we have a donor PCM. I used a hot heat gun to get the cover off, and I sprayed some deoxit in here. I'm going to blow compressed air from the bottom. If we see bubbles here, that means water is also able to go into the PCM and mess with the board. So you see the 6 power transistors for the ignition coils right there, and I'm guessing there's 6 of those, but this is where the ignition coil stuff happens, and this is where the water intrusion was. And unfortunately you can't get this board off of the potted, you know, glue. You see the little spaghetti, the yellow spaghetti coming through. So let's try that. I'm going to blow compressed air from the backside. Here, let's put a little more liquid on there. Set the camera up right here. Blow from the bottom in that vicinity. So let's check it out. There it is. You see the bubbles forming on the pins? Right there. So if air can get out, water can get in. I'm afraid that PCM is cooked because it was being drenched in water, and water is pooling down here and got into the PCM and messed this up. So we could try to open up the replacement PCM, see if there's any green crusties on here, but the truck still runs on that one. That's the only one that the truck runs on at the moment. So with the original PCM, I see there's a little hole up here at the top of the connector. This is the bottom where all the green crusties were. So this is another check. Pour some deoxit in there and then blow through here. You can see all the bubbles. Those pins are not watertight or airtight. Can you clean it like that? I don't know. That's crazy. Massive water intrusion into the PCM, unfortunately. That's my final call. These guys need a new PCM program. I can't do the key programming. I didn't even bring my key programming tool, unfortunately. You can see all the green corrosion coming out of there. Yikes. Do a little deoxit dash, see what happens. But I don't have high hopes for this. Here goes nothing. We're going to try key programming. We've got a code from the dealer. It's 5-digit pin. Let's see what happens here. Alright, here we go. BCM, mini crypt error signal compare failure. So I don't know if just key programming will be enough. So that's the correct VIN, and in the PCM we should have the correct VIN. I don't want to erase the keys and make this thing a beached whale. Let's see, special function, check VIN. Okay, yep, the correct VIN. Should we try it? Okay, so we got 2 keys. Any existing keys for this vehicle which are not reprogrammed by the end of this procedure will be disabled and will no longer work. Okay. Yes, we have all the keys. Number of keys programmed is 4. Must have the vehicle's electronic code. Ignition must be off for the remainder of this procedure. Turn the hazard lights on. 5-digit number. Okay. Found a customer-owned programming card. Let's try it. 48591. Okay, inserted the key. Key successfully learned. Please continue. Okay. Key type, mechanic key learned on BCM. .rf, okay. Is that it? Do you want to program more keys? Yes. So, insert this. Okay. Key successfully learned. Okay. So no. Please confirm all keys intended to use in this vehicle have been programmed. Yes. You turn off the hazard lights and test the keys. Okay. Nope, not gonna work. Just like I suspected. So PCM programming, keys program 2. We'll pop the original PCM in. Yep, it's still there. Let's try the other key. Once you get the mobilizer light, it'll run and install. Okay. So that's all I can do. This thing has to go to the dealer for proper PCM, BCM matching, and that's it.